Greetings and welcome, friends. Mr. Waddy here. We're taking a look at 3.3's homework. What was that? Page 124. We've been talking about graphs and functions and lines and function notation specifically from this lesson. So we've got this, it says evaluate the function when x equals -2, 0, and 5. And so this says p of x. So that means the input is x and the output is this p of x function, okay? And so if I want to figure out what the function is equal to when x is -2, I would have p of -2 equals -3 plus 4 times -2. Okay, so I'm plugging it in as the input, and p of -2 represents the output, or right, it's equal to what I get when I simplify this, which is exactly what I'm going to do. I'm just going to PEMDAS this. So -3, 4 times -2 is -8. -3 minus 8 is -11. So P of -2 is equal to -11. That means when I plug in -2, I got -11 back. It is equivalent if I wrote this as the ordered pair -2, 11. It is equivalent if I graphed this, if I went left 2 and down 11. That's the graphical solution, right, of -2, -11. These all represent the same thing, okay? And so yesterday we were talking about this function notation of how we can represent that. Let's see, let me actually undo some of that. Let me find out what p of 0 is. So plugging in 0 for the function means I'm replacing x with 0. So let's see, -3 plus 4 times 0. If there were multiple x's, I would replace each of the x's with 0. Let's see, -3 plus 4 times 0. Well, 4 times 0 is 0, so equals -3. So p of 0 equals -3. And lastly, let's do p of 5. -3 plus 4 times 5, and I get -3 plus 20 equals -17 is what p of 5 is equal to. All right, so that's the idea. Evaluating a function means to plug in a number as its input and tell us or derive or write PEMDAS, just order of operations, what the output is going to be. So that's what we end up getting there, like so. Let's see, interpreting function notation. These ones, I really like these ones. These ones really get me thinking. It says, let's see, let C of T be the number of customers in a restaurant. So the output is C of T, and that is the number of customers. All right. And the input, T, is going to equal what? The hours after 8 a.m. So I might even say number of hours after. After 8 a.m. Okay, so now we've got to think about what this means. So for A, what does C of 0 mean? C of 0 equals 0. That means the output, right, the number of customers is equal to 0. So I'm going to say there are 0 customers. We didn't have people waiting outside, camping in tents. Let's see, at time equals 0. What does time equals 0 mean in terms of this problem? Well, 0 hours after 8 a.m. would represent 8 a.m. So there are 0 customers when they open the shop. Well, actually, we don't know they open the shop at 8 a.m. But I was assuming. But nonetheless, that is the case. Actually, it's interesting, like this sort of thing, I don't know where Google is doing it, but somehow they are tracking when stores are busy. Have you guys seen that? They've got like a little bar graph with like 3-hour increments, and I can like figure out when my hardware store is busy or when like the local restaurant is busy. like where, I don't know where they're getting this data. Are they tracking it from like the number of transactions at the register somehow? I don't know. Hopefully they're not just like pulling all of our credit card data or something. Let's see B. So they're saying C of 3, the output at 3 hours after 8 a.m. is equal to the output or the number of customers 8 hours after 8 a.m. So let's see. So the number of customers, what is 3 hours after 8 a.m.? Let's see, 8 plus 3 would be 11 a.m. So 11 a.m. is the same as the ditto number of customers at, let's see, and then 8 hours after 8 a.m. Well, let's see, that would have been 1,600 hours in military time. Or I could think about 8 plus 4 of those would have put me at noon, and then another 4 would put me at 4 p.m. All right, 1,600 is 4 p.m. I don't know if you guys have ever done the military time thing, but there you go. Let's see, C. Okay, so for this one, N hours after 8 a.m. So I don't know what time this actually represents. There are 29 customers. All right, we have no idea when that is. We just know that with this little fact, that's what that means. N hours after 8 a.m., you get the output of this function is 29 customers. Let's see, how about this last one here? D, the number of customers, the number of customers at, let's see, 13 hours after 8 a.m. Well, 12 hours after 8 a.m. would be 8 p.m., and one more hour is going to be 9 p.m. So this number of customers, 9 p.m. customers, is less than, and let's see, let's use my cheat little ditto marks, less than the number of customers at, let's see, 12 hours after 8 a.m. is 8 p.m. All right, now it doesn't tell me what those numbers are. I know how they relate in terms of size. That's it. So I don't know how many are there at 9 p.m. It could have been 0. Maybe the store closes at 8:30. I don't know. But right now, I do know that there are fewer customers at 9 p.m. than there are 8 p.m. So just kind of being able to interpret what this function notation means, I actually really like these problems. Good job, Big Ideas book. I'm impressed. I'm impressed. Let's see. 15. It says, find the value of x so that the function has the given value. So here's my function. All right. And I want to know is when is the output 7 is the question I'm asking. So the output is 7 at some point. So what we'll end up doing here is taking the 7 and plugging it in, not for x, but for m of x, this entire thing. Okay, so that's kind of a weird idea, I know. So I'll have 7, I'm a little wobbly in my writing today, equals 4x plus 15. So to solve for x, right, so that one step was the new idea, and now we're just going to use our old solving skills back from the days of chapter 1. So how do I get x by itself? Thoughts, friends? What do we do? Subtract 15. I like it. I could divide up everybody by 4, but unless you're a fan of fractions, I would not recommend it. 7 minus 15, well, the signs are different. Let's not freak out. So 15 minus 7 is 8, and we'll take the sign of the more influential. 15 was more influential than 7, so that's a negative 8, equals 4x. And now the inverse of multiplying by 4 is dividing by 4. Save your fractions till the end, friend, if you can. Negative 8 divided by 4 is going to be negative 2. So that means, if I wanted to write this in function notation, that f of negative 2, m. Sorry, a function, I assumed you were f. Let's see, m of negative 2 is equal to 7, is one way that I could think about it. I also could write that as the ordered pair negative 2 comma 7, right? Left 2, up 7 on the coordinate plane. Okay, I think I've got one last example. Actually, no, two, but super fast ones. And it's actually asking exactly the same question, but from a graphical perspective. I like these a lot. So it says, find the value of x so that f of x equals 7. Bless you. So what I'm going to do is line this up with 7 on the y-axis, which is the output, and I'm going to trace it over to here, okay? And I want to figure out what was the input that gave me the output of 7. Now, for functions, there technically could have been multiple inputs that gave me that output, as long as each input had exactly one output. As long as, right, it passes the vertical line test. But horizontal line, it could hit multiple times. So let's see. So I'm going to trace over from the 7 and figure out where this point is, and I'm going to end up tracing down. Let's see. Whoa, oh dear, I was all set to be super smooth, and then I grabbed the wrong point. Let's see. I'm going to do the same thing for this graph. So I'm going to trace over from 7, and now we're gonna go down to the x-axis and find the corresponding value. Let's see, so what input gave me 7? Well, here it looks like that input would have been x. Oop. That's funny, I still had the line tool on. It looks like 5 is the value there, and over here, if I was to trace down from the point that gave me 7, it looks like negative 3. So here, x equals 5, and here x equals negative 3. I could have thought of this as f of 5 equals 7. Right, over here I could have thought the input of negative 3 gives me 7. So these were asking actually the same question as the problem we just did, 15, except we had a graph to work off of rather than an equation. And notice, right, I was able to, figure out when was that output happening and then trace it back to that corresponding input, right? Same idea here. When was this output happening? Well, I'll plug 7 in for the output, and then I traced it back to the corresponding input that gave me that output. All right, so thanks for watching, Internet friends. Tienen un día el más bien del mundo.